Hey guys, welcome back. This is Mr. Yu here, about to hit you with another electrifying math lesson. Don't forget to like and subscribe. Leave a comment down below telling me who's your favorite math teacher, me or Mr. Mastella, at least as far as recording ourselves, because I'm having a blast. So we're still on the topic of properties of logarithms. Yesterday we were expanding logarithms. Today we are doing the exact opposite, condensing logarithms. So we're going to be simplifying logarithms down using the same exact properties that we were using to expand them. So we had the product property right here. So whenever you're multiplying two things together, you can split it apart into using addition. The same thing works opposite. So if you have two logarithms that are adding, you can bring them together and to be one logarithm. If you multiply, you still have the quotient property. If it's division, you can change that to be subtraction. And then you have the power property. So we're going to use those same properties, but backwards. So these first three are going to be one of each type. And then, as you can see on the right side, is just extra examples if you want to see a couple more worked out. So the first one, you have log 3 of 5 plus log 3 of x. So we want to condense this down into a single logarithm. Now what's important here is that this only works if you have the same base. So as long as they have the same base there, so in this case they both have a 3, then you can bring these together to be one logarithm. If they were different numbers or variables or whatever, you wouldn't be able to combine them at all. You just have to leave it. So on this problem, I see that these two logarithms are adding. Remember, whenever you're adding, that's the same thing as multiplying. So you can bring these together to be a single logarithm. So log 3, and then you're going to have the 5 times x. Now, we normally don't leave it that way, though. The way you're usually going to see it written is log 3 of 5x. So that's what it should look like. The second example, log b of 18 minus log b of 9. So again, make sure that these two bases match each other, and as long as they do, you can condense them into a single logarithm. Subtraction changes to be division. So this would be log b of 18 divided by 9. And as always, if you have a fraction, try to simplify it. So then the simplified answer would be log b, and 18 divided by 9 obviously is 2. So that'd be the answer for that. And then the last one is an example of the power property. So in this case, we have a 2 that's in front of the logarithm. And what that's going to do is that's going to come back and be the exponent for the 5. So then what this is going to look like is log n of 5 squared. And then to simplify it, 5 squared is 25. So final answer, log n of 25. So if you understood these, you can skip ahead to the next section. But I'm just going to do a couple more examples. That way you've seen multiple examples of each. So for example D, you have the 3 there. That's going to come back and be the exponent for this x. So then the problem's going to look like log 8 of x to the third power, or x cubed. Now you can't do x to the third power because that's a variable, so that's as simple as that one's going to get. The next one, again, keeping in mind that they have to have the same bases before you can combine them. So this one both has m's, so you can combine them to be one logarithm, and it's subtraction, so subtraction is going to combine using division, so 6 over 15, and it has to be in that order, 6 on top, 15 on the bottom, because that's the order it was written in. And then as always, simplify your fractions, so log m 2 over 5 when I divide it by 3 for both top and bottom. And then for the last one, you probably noticed that the 4 and the 7, so the bases were different because These two are different bases. That means these cannot be combined or can't be condensed. So then that's as simple as that one can be written. You're never gonna see that one, but I just wanted to emphasize the fact that the bases have to be the same in order to combine. This next example is more condensing, except now you have multiple properties in a single problem. So example A, I see that this one is addition, and again, make sure that you have the same base. So addition can be combined using multiplication. However, this logarithm has a 5 in front of it, and that 5 doesn't let you combine it just yet. So what you have to do is you have to take that 5 and move it back to be the exponent for the y first, and then you'll be able to combine the logarithms. So move the 5, it's going to look like log 3x plus log 3 y to the 5th power. We can't simplify y to the 5th power, so you can just leave it how it is. And now that we've gotten rid of the 5 that's in front of that logarithm, now we can combine both of them into 1. So this would be log 3, and then you're going to have x times y, so you can just write x, y next to each other. So it looks like that. If you wanted to, you could put parentheses, but it's not necessary. The second example, notice how this one has parentheses here. Remember, parentheses tell you that you need to prioritize these two, so you're going to combine those two logarithms first, and then after you combine those, then you can combine it with the third logarithm. So combine these two. This one is addition, so you're going to combine using multiplication. So this would look like log 2 of x times y. Drop down the other logarithm. And then now this is subtraction. So subtraction you combine using division. So condense them into one logarithm, and it's going to be xy being divided by 11. And that's your final answer as far as condensing it goes. Now obviously these have variables, so that's why we can't simplify it any further. The third example, I see that this logarithm has a 2 in front of it, so we need to move that 2 back before you can combine the two logarithms. So then this would be log 7m squared minus log 7m. And then since they both have the same base of 7, you can combine into a single logarithm. Subtraction is going to combine using division, so m squared divided by n. And there's your answers. So these are your simplified forms. We're going to be condensing logarithms into a single logarithm once we start solving equations. And the last example is using the inverse property that I mentioned earlier. So if you have if you have a logarithm where the base matches this number, they actually cancel each other out. So these would cancel out, and your answer is just whatever's left. Same thing the other way. If you have an exponent and the logarithm, both have the same base, they cancel each other out, and it's whatever you're left with. So these next three examples are going to be really easy. So this first example, well, it's missing something, right? It's missing that base here. So whenever it's missing a base, that's a common logarithm. So you assume that it's a 10. And then since the base matches the base of the exponent, they're going to cancel out. So this gets rid of this. Final answer is 2x. On the next one, super easy. The 2 matches the log base 2. So that means your answer is just the 27. And last one, same thing. Logarithm has the 8, and you have the 8 here, so they cancel. So your final answer is 3x plus 1. So inverse property can be useful. You can just cancel everything out really easy. Here's your homework for tonight. Make sure to submit it through Edsby. And if you have any questions or concerns, just send me a message and I'll get back to you as soon as I can.